Hello, everyone. We are North Carolina A&T students, and we're here to present this tutorial on the visual ARM emulator application. This is good for any type of architecture classes or any labs that have you writing machine code specifically. So first, we're going to start off with installation and setup, which is actually quick and easy. So here we are on the home page of Visual. This should be given to you in a link of some sort. This is where you're going to download it from, as well as see some other tips and tricks they have listed on their website that is not put in this tutorial. This tutorial is highly specialized, and this website covers a lot of extra stuff that you may or may not need to know. So first things first, you're going to go up to here on the downloads area and click on that. And here you see a bunch of download options. This is where you're going to download it from, and you're going to choose the option based on your machine right here. I have a Windows, so I'm going to click on that. Once you click on it, it should start downloading. Once the download is complete, you're just going to click up here on this and open it up, and then we'll go on to the next step. So this is the file, this is the folder specifically that you just downloaded that comes with Visual. And this is going to be quick and easy. You're just going to click on this and a pop-up should appear. And this is asking you to extract all of the compressed stuff in the folder. It's just going to do a lot of work for you that makes it easier to work later. And so you're going to hit extract all. And then here it's telling you where do you want to put this folder, what do you want to name it. I recommend you put this in an easy to access place in case you want to use it all over and over again. And then this is what you're going to do. You're just going to extract it and then just let it run for a second. Once it's finished running, this is what should appear. You're going to see the visual icon has changed, but the other files are still there. And this is the actual application we're going to use. You're going to click on this and open it up. And there you go. This is the application open, ready to use and anything to do. You can change it around, move around, do whatever you want, move it full screen. There's a couple things you can do up here with like new or open up existing files, save your new files, tools, stuff like that. Well, yeah, it should be ready to use, and the rest of the tutorial will tell you how to use it.
Hello, my name is Camryn Agee, and today I will be giving you a tutorial on Visual, and I'll be going over a few of the basic commands, some of these including the move command, the add command, the subtract command, as well as the logical and or commands. So the first command that we're going to be going over is the move command. And this instruction is used to move data from one location to another. For example, if I want to put the number 10 in register 0, I would simply type move R0, which is the destination. And then I'm going to do immediate, the sign for immediate number, which is the pound sign, and then 10. I'm going to press step forwards. And as you can see here in the top right, it now says A. It says A because that is the hex equivalent for 10. So the next command that we're going to go over is add. So this one, it takes two registers, adds them, and or numbers, and adds them and puts it into a destination register. So, for example, add. So now we have R0 has 10 in it, so we can do this. So add R0. So this is the destination, and then we can put two register. We can put register and a number there, or register and another register. So let's say R0, R0. So this is what this is going to be doing is the first R0 is going to be the destination. The next two are what it's adding. And we know 10 is in register 0. So it's just adding register 0 to itself. So 10 plus 10. So if we step forward there, so it's going to run the first command here, the move command. So now our register 0 has 10 in it. And then now register 0 has, this is 1, 4, but this is in hex. So if you want to get the equivalent, the decimal equivalent of that, we're gonna have to convert it. So this ones place is 16 plus 4, so that's 20. So 10 plus 10 is 20. Okay. So the next command is I'm going to do is subtract. So that takes two registers and subtracts them and then saves it into the destination register. So I'm going to add some other registers in here too. So let's say move R1. Let's say 15. Oop, there we go. So what this is going to do, it's going to put 10 into R0, going to put 15 into R1, and then it's going to subtract them. So it's going to subtract 15 from 0, or no, 15 from 10, and then save the result into R0. So it should be 5. So we're going to step forward. So it's 10. And then R1 is 15. So that's why it has the F. That's the hex equivalent. And then if I press it again, R0 is now 5 because it subtracted 15 by 10. So next, I'm going to be going over how to add bigger numbers into these registers. So you're not going to be able to add a 32-bit number into a register all at once. You can only use a max 8 bits, move 8 bits at a time. So for example, I'm going to show you what I mean by that. I'm going to get rid of this. So for example, move, let's say R0. We're going to do a hex number. So 0x, immediate, 0x. And we're going to say F, FF, FF. So this is just 15, 15, 15, 15, 15. Anyway, so this is a 4-bit number, and it's going to give me an error when I run this. See, it says runtime area, immediate operand value, immediate must be creatable by rotating an 8-bit number within a 30-bit word. What she's saying is just you have to do 8 bits at a time here. So if I want to make this number, move this number into R0, it's going to look a little different. So let's reset here, and we're going to edit this. So you can only use 8 bits at a time. So I'm going to set it like this. So I have FF here. So this is only moving in those first 8 bits. And now I'm going to have to use what's the OR command, logical OR command, to do the rest of this. Zero R 0 0x. So yeah, so this command, the first command line here is doing the first 4 bits, and then the bottom one here is doing the last 2. So it's filling in where these 2 zeros are. So when I finish running this, this should have R0 up here in the top right, should have 4 Fs in it. So step forward, yep, there's the 2. Step forward again, now it adds the 2 more. So if I want to do a 32-bit number, so 8 Fs up here, I would have to do this a few more times. So I'm going to add 1, 2, 3, 4. So that's 1, 2, 3, 5, 6, 7, 8. So, yep. 2, 3, 4, 5, 6. I'm just going to copy this, paste. So, yep, this is taking the first lines, doing the first two. This one's doing the next two, next two, and the next two until I have a total of 8. So there's the first two F's in there. Then there's the next two, and then finally the final two. So now this is a 32-bit number that is in there. So we shouldn't be able to add any more into R0. So let's try to see if that will. So yeah, it doesn't change it at all. So it still has 1, 2, 3, 4, 5, 6, 7, 8. So it's still the same. Right. Yeah. And if you try to do more than that, it gives you an error. So I have gone over the some of the basic commands and visuals in Visual. I hope this was helpful. Thanks for watching.
All right. Now I want to step you through some slightly more advanced topics with visual, starting, well, these advanced topics will be branches and loops. A branch is, well, if you're acquainted with any sort of high level programming language like Python, Java, C++, you can think of branches as like the start of a conditional. If so and so, if x equals 5, then do this. You can think of some branches as the beginning, the entrance into that sort of code. I'm going to give you some examples to help you understand. So here, this is, well, ARM assembly language. Starting off by loading the immediate value 15 into register 5, the immediate value 7 into register 3, adding the value in register 3, which was 7, to 8, and storing that in register 0, so that register 0 has a value of 15. Now, CMP is going to compare the value in R0 to the value in R5 and set flags. Now you can see the flags down here, the ARM status bits. And there are more things you can do with this, but for now, what you need to know is that you're comparing the two. If it's equal, it'll set a equal flag, and the next branch. Now, our branch is started, or rather taken, with B. This EQ here is basically like saying equals. So this branch is only taken if the equals flag was set, which it was here, since R0 and R5 were both 15. Since the branch is taken, the branch is named equivalent, it will immediately, the next instruction will be where the target is. The target is named equivalent, and in the next step, or you can see the pointer here, it'll go to the next line after the target, which will add R0 and R5, which are both 15, and store them in the value of R0. So R0 at the end of execution will have a value of 0x1e, or hex 1e. Or if you'd like to see that in decimal, 30, 15 plus 15. Another example. Now, keep in mind, this was a conditional example. This branch is only taken if R0 and R5 were equal. If R5 was 14, if R5 was any other number, then R0 would have been 15, R5 would have been any other number. The branch would not be taken. In fact, let me just show you. The branch would not be taken, and instead, it would do this subtract instruction right here. See, loads 12, loads 7, everything's the same up until this. It compares R0 and R5. R0 is 15. R5 is 12. The branch equivalent, they're not equal. So the branch is not taken. It subtracts R5. I'm sorry, it subtracts R3 from R5, which R3 is 7, R5 is 12. The value in R0 becomes 5. And that does not mean the instruction after the target is ignored. It is still taken. So R0 is added to R5 and stored in R0, leaving R0 with a final value of 11. Now, let's look at a unconditional example. This is a lot simpler, easier, and often how you're going to start a loop, but I'll show you that later. So in this example, we're just going to load R0, register 0, with the value of 0xBE. Yeah, I thought I might do that. Which, if you'd like to know what that is in decimal, you can always click up here, and it's a big number. We don't need to worry about that. Now, after that, the branch is taken. There's no EQ. There's no GL. The branch is always taken regardless of what happened before it, unless another branch would skip it. But that's not here. The branch is taken. The target is target. So the next instruction is skipped. It goes straight to the subtract instruction and subtracts from R0 13 and stores it in the value of register 1, leaving register 1 with a final value, well, of R0 minus R1. And that's it. There's no way to make this branch not happen outside of just skipping it. So, where is that most useful? Well, I don't know about most useful, but it's very useful here. The target for a branch, if I think you can see my mouse, the target for a branch can be before the branch is made. So you'll see here in this loop example I have here, the branch is here. The target is loop. The target is 6 lines above the branch. That works just fine. There's no issue with that. This is how you can implement a loop in ARM assembly language. So we're going to load R0 with 5. We're going to load R1 with 1. We're going to compare R0 to just 0. R0 is 5. Well, 0 is 0. They're not equal. Therefore, this branch, done, won't be taken. It's not done. 5 and 0 aren't equal. The branch, or rather the loop, is not finished. So we skip it. Add R0 and 13. And store that in R2. Add R2 and R0. Store that in R2. Subtract R1 from R0. This is the most significant instruction here. I want to point that out. These add instructions, these are, you could make anything in here as long as it doesn't modify the values of R0 and R1. Of course, you could do that if you wanted to, but I have these here specifically so that it doesn't interact with the loop. This subtract instruction subtracts the value in R1 from the value in R0. So it goes from 5 to 4. The loop is taken. Compares these two. Now R0 is 4 and 0 is still 0. They're not equal. So it continues to do the same thing over and over until it's taken again for the last time. It compares R0 and R0. I mean, R0 and 0. Now, since R0 is now equal to 0, the branch done is taken. The rest of this is skipped over, done, go straight to done. Execution would continue after done. Since there's nothing else left, that's done. These are 3 fairly simple examples of branches in Visual, and I hope that helped a lot.